This is my sweet spot. Hot tea, milk, and lots of sugar. This is wonderful. But what is it when we talk of the sweet spot of an engine? What is it really? Well, it's the performance point at which an internal combustion engine, and in this case a diesel engine, is most efficient. Let's look at this schematically on a BSFC chart. That's quite a mouthful, but it means brake-specific fuel consumption, and is the rate of fuel consumption divided by power. This is a value which relates to the fuel efficiency of the engine. On the horizontal axis, we show engine speed in RPM, and on the vertical axis, engine power. These lines indicate power at various engine loads expressed in percent load. This is just like a topographical map showing mountains and valleys. These lines are lines of constant specific fuel consumption. They are like the topographical maps that hikers use to indicate low or high points. So this is the point of lowest specific fuel consumption. This is the point of highest efficiency, and therefore the lowest fuel consumption. This is the sweet spot. Every engine manufacturer has charts like this, but they're not made public. But what do we know by looking at charts like this? Firstly, the sweet spot of a diesel engine is at high load and low engine speed. So why is this? Well, lower engine speeds leads to lower friction losses and lower pumping losses. And high engine loads means that there is less mechanical effort in rotating the engine. It's only in the last few years, with the advent of improved electronics, that down-sped engines have been able to realize better fuel economy. Old-timers like me will remember the old engines where you had to really run the engines out at high speed to extract useful power for propulsion. Modern down-sped engines have peak torque available at speeds as low as 1,000 RPM or less, with peak power available also at lower RPM, all bringing it closer to the sweet spot of the engine. Fuel efficiency is improved by about 1% for every lower 100 RPM in engine speed. Engine load can be raised also by downsizing the engine. All of this meaning that the fuel efficiency of the engine is improved. However, doing this requires a total review of the powertrain. Firstly, this requires faster axles. That means lower numerical numbers. So with ratios in the order of 125 to 120 to 1 allows you to cruise at 11 to 1200 RPM at 65 miles an hour. Of course, this necessitates an entire review of the driveline system. This means uprated U-joints, differentials, and axles. Part of the package is the use of automated manual and fully automatic transmissions with small steps, which allow you to cruise at or very close to the sweet spot of the engine. Shifts are made seamlessly as you cruise down the road under various load and grade conditions. Every diesel engine has its own unique BSFC curve. It's like a fingerprint. It's incumbent on every user to know at what speed the engine operates most efficiently. This is what running in a sweet spot really means.